So very good evening once again to everybody, and welcome to our session 1 in DLCOA. This is subject of semester 3, and around 7 minutes I will spend in general planning of this subject, how we are going to complete this subject, and of course some introduction about your teacher. So let's start from me, and you can see my small profile in front of you. My name is Professor Atul Oak. I'm working as assistant professor with VIT, Vidyalankar Institute of Technology, in Department of Electronics and Telecommunication. And you can see my academic profile. I will not go into that. It is just for your reference, because you must know about your teacher before we start. So all academic profiles you can see on my initial slide. I think you have read. I'm with Vidyalankar for more than 15 years, and mainly my teaching domain is system architecture. And in system architecture, I teach all these subjects which you can go through, starting from microprocessor, microcontroller, your subject, computer organization and architecture, till IoT. And of course, these subjects need programming knowledge. So I also teach programming from C, C++, Java up to assembly language. So this is my domain of teaching, typically system architecture. Like I said, I'm with Vidyalankar from last more than 15 years, and teaching all these good subjects, rather interesting subjects. And now let's talk about your subject. Your subject is DLCOA. It is CSC 304. That's the code. And typically the scheme is 80 marks of EAC, that is final examination, 25 marks of term work, what you do in labs, internal assessment of 20 marks, IA1 plus IA2 divided by 2. And total is 125 with 3 credits. That is the look of the subject. And these are the main contents or chapters or modules in DLCOA. Total 6 modules. And on right hand side, what you will find is our plan, how we are going to complete. So if you observe little carefully, you will find small change is there in our plan, how we will complete. We will start with module 1, of course, day 1, session 1, then module 2, then we will complete module 5, then module 3, module 4 and module 6. That is the sequence I will be teaching and we will be completing. Main reason why this sequence is slightly changed: if you want to study module 3 and 4, and of course module 6, because that is the advanced techniques, you have to know about memory organization. So because that concept we need in module 3 and 4. So our plan is 1, 2, then module 5, module 3, module 4, and module 6. Okay, so this is a way we will be completing all 6 modules of your subject. Let's talk about some planning part. You are aware our schedule is every Friday online at 6:30 for 2 hours and 15 minutes. Such 14 sessions I will be taking to complete the syllabus. So 14 number of lectures. We may require 1 or 2 sessions depending on your response, how you answer my questions, how you understand the concept, at what pace you can grab the concept. So accordingly, some buffer of 1 or 2 sessions. So 14 minimum and 16 maximum, that is the requirement. Lesson plan is ready. Detailed lesson plan is already shared with the office. You will get it once you are registered and formalities are done. Now this is online session, so probably best way to communicate is chat box. Now we are expert in online, that is what I believe. So if you want to ask any query, if you want to ask any question, if you want to answer any question, because a lot of questions I'll be asking, it's interactive. Best way is chat box, and of course, occasionally, if you want to talk to me, you can raise the hand. Okay, there is a facility called raising hand, and you can use it. I will understand you want to ask, you want to talk, and you can communicate to me. Of course, in between, I will ask you for your queries. Okay, so it's not a monotonous type of talking. Okay, I'll be talking to you, I'll be taking feedback from you. Okay, your queries, your questions. And I expect that you should be a good active participant. Okay, try to answer, try to raise the questions, give me your feedback, because we are online. So my voice, my presentations should be clearly audible, visible. And finally, since we are working in a definite time frame, okay, we have fixed time to complete syllabus. I expect that you should carry one notebook, write important points when we are discussing. Okay, I may not dictate every now and then. Okay, dictation we will avoid. Of course, I will give you some important concepts for some topics. Okay, because main focus is on examination. So for some topics, I will give you some dictation also, but not in every session. Why, you will understand in next slide what is the thought and the organization. But what I suggest is you try to carry one notebook, and whatever points you find important, note it down. Okay, in your own language or in your own words. Okay, why? Reason is your main study reference is the soft copy of notes which are already available in app called StudEase. This is the app you will find in Play Store, and in that all notes are already available. Detailed notes are there. What you want more than that is there in the notes. Okay, that is the reason our focus is on concept. Some important dictations I will give depending on the topic. Okay, occasionally. All these PPTs, what I'm using for teaching, I will share in a form of PDF. So this all will be available to you in this app. Okay. And one textbook that I will recommend, if you have a good reading habit, you should. Then for this subject, the best textbook is Computer Organization and Architecture by William Stallings. Okay, this particular textbook is a very detailed textbook. Of course, not all chapters you will require. So you need to see the module and refer this textbook. Very nice textbook for general reference. And prerequisite for this subject is some fundamentals of computers you might have studied in SEM 1, and some programming language like C language, because I think you have studied C programming in SEM 1. Okay, that's the prerequisite. Some reference we will take as we go with this subject. And this subject is one pillar in computer engineering, because if you want to understand your higher semesters, then this is one of the pillar. That's the significance, and that care you have to take when you are studying. Now all is good. I'm ready to start our session 1. If you have any further queries, you can raise. But I just talked about little more than 10 minutes for general organization. So check if any clarification is required. You have any query about what I discussed as the administrative part of our sessions. So check if any specific query you have. You can ask in chat box. I will just wait for a few seconds if you have any query. Otherwise, we are good to go. Okay, now last point before I start. There is a magic word called yes, YES. Okay, now what is YES? Occasionally, I will ask you, am I audible? Is my screen is visible? Is all is good? In that response, you should write YES. Okay, that means all is good. Technologically, we are connected, and that is important because I must know you are there and I'm audible. Okay, so let's start with the question. Is everything is good? Am I audible? Let me check what is your response. Yeah, that's great. So that's the magic word. So it means that all is good. Okay, fantastic. Now we can start. Okay, let's start with session 1. Let's see what's the plan. Okay, because if we plan, we can do. For session 1, okay, let me answer one question. I think I can see one question in chat box. Okay, so there is a question and Ranjil wants to know about the subject. Let me answer this question. This particular subject is concept oriented. I said it's one pillar in your higher semesters. and major concepts in computer you will study from this subject. From this subject you will study next subject called microprocessor in semester 4, and there are lots of numericals in this particular subject. Okay, so many numericals are there, many algorithms are there. So this subject is concept oriented numerical subject. Okay, I think that is the best answer I can give. Anyway, now I can go ahead. I think I answered that question. For the day, let's see what's the plan. Plan is, we will start module 1 called number systems. I will introduce what is a thought. We will start convergence between number systems. Okay, you might have started in your institutes, might have completed also, because it's a big race. And we will try to introduce a concept of standard code. Okay, expert time, because main focus is your understanding. Okay, I'm not in that race to complete. We will definitely run the race, but with proper understanding. Okay, let's see module 1. I hope everybody is alert. Questions are coming. Let's start with a question. What is a computer? Everybody knows about computer. Like humans, computers are everywhere. So my question is, what is a computer? Your answer in chat box. Let me see. What are your thoughts? Okay. Electronic machine that processes input and produces output. Okay. Electronic device. Okay. 20 seconds if anybody wants to answer. Only 2? Oh, that's a big answer. Ashaf has given a big answer. Okay, that's fantastic. I can see a lot of answers. Yeah, very nice. Fantastic. So I'm happy you know what is a computer. Okay. Let's move on. The question is, what is a computer? This question is important because in your subject there is a computer, DLCOA, C for computer, and you are from computer engineering. Okay. Different branches, computer science, computer engineering, ... The best definition of computer is here. We always say computer is electronic machine that processes the data at high speed and generates valid result. A short and sweet definition. Okay. Computer is electronic machine that processes the data at high speed and generates valid result. Now, let's understand a little more. Why electronic? Because if you open your desktop or laptop also, you will find there are a lot of ICs inside. Okay, integrated circuit. So we say it's an electronic machine. And what is processing? Simple addition, subtraction, or sorting, SORTING. Okay, recollect C programming or probably Java programming. Searching. Okay, that all is a processing. You have to find largest number or arrange numbers max to mean. That all is a processing. Okay. Now the question is, if computer is electronic machine that processes data, how this data is presented in the computer. I repeat, my question is how this data is presented in the computer. How this data is stored in the computer. Example, we human use lot of symbols, alphabets, digits to represent the data. Okay, now we are talking. Our communication is in English. That's the data. Okay, what I'm sharing is data using English, using alphabets, words. Okay, point is, human use lot of symbols or alphabets, digits to represent the data. Okay, like that, how my data is presented in computer? That is the basic question. Okay, I can see some answers, and there are correct answers in chat box. Answer is any data. Okay, let's say integer data. We always represent using decimal number system. Okay, we humans always talk decimal number system, digits 0 to 9. Okay, if I want to provide my mobile number, then all digits are from 0 to 9, and such group of 10 digits is decimal number system. Okay, so we humans always talk decimal number system whose base is 10. And very interesting observation. Why 10? How this decimal number system was invented? Why not 8? Why not 5? Simple reason is human has 10 fingers. Okay, and because human has 10 fingers, the natural tendency of human is to count 10 digits 0 to 9. That's why we human, we use decimal number system. Okay, logical, of course, logical. Like that, how my data is represented in computer? Because now we are very clear, we know what is a computer, we know how we talk data as a human. So now we think how our data we represent in computer. That answer is using two symbols, 0 and 1, called bits. Okay, good. I can see direct answers. Okay, using two symbols, 0 and 1, called bits. And what is a bit? It's basically a full form, binary. Okay, from that we take bi, and digit, from that we take t, so it is called bit. Okay, bit, that is binary digit. And plural is bits. Okay, of course, multiple is bits. Let's summarize what we have gathered. Computer always represent data using bits. There are two symbols, 0 and 1, and we call that system as binary system, or I will say base 2. Why? Two symbols, 0 and 1, that is base 2. Human, base 10, 10 digits, 0 to 9. Okay, this is called number system. So basically, number system is a thought where we represent some standard symbols like digits, 10 for humans, 2 for computer. Okay, so it's a group of symbol. Basically, number system is a group of symbol like digits, Up to this, if you have any question, then you can raise your question. Otherwise, I will go one step ahead. Check if you have any questions. If you want me to justify any point, I just introduced what is the thought of number system. So my question is, any questions? Check if any questions. Otherwise, we can move. Yeah, I will answer that question, Deepesh. MSB, MCB, LCB. I will answer it. Just wait for next half an hour. Okay. And it is not MCB, it is called MSB. And it is not LCB, it is called LSB. I will talk about it. Okay, so there are no questions and I can move. Fine, let's go one step. Here we go. No, that's okay. Nothing to say sorry about it. I thought you are a little confused, so I said it is MSB and LSB. Anyway, now let's talk about number systems. Okay, I said two number systems. One is 10 and second one is 2. But typically in computer, we talk about 4 number systems. Any guesses? What are the 4 number systems we commonly use in computers? 2 I talked. But any inputs from your colleges, you can share. What are the other number systems? Any answers? Yes, that is right. So the remaining 2 are called octal number system and hexadecimal number system. That's correct. All the answers I can see, they are perfect. So let's summarize. And here is a table, okay, where you see those 4 number systems. One is decimal, second one is binary, third is octal, fourth is hexadecimal, and you are aware decimal means total 10 digits, 0 to 9. Binary means 2 digits, 0 and 1. This is called bits. Octal has 8 digits, 0 to 7. And hexadecimal means base is 16, okay, 16. This is slightly different, okay. If you see the symbols, you will find that in hexadecimal, there are digits from 0 to 9, just like decimal. And there are some alphabets from A to F. So total 16 digits, 0 to F. And these alphabets are not characters. Please understand. Normally in programming, you say A, B, C, D. They are all characters. But these alphabets are not characters, but they represent numeric value. Okay, like A represents value 10. B represents value 11. C represents value 12. D represents value 13, 13. E represents value 14, 14. And F represents value 15, 15. Okay. Now the very fundamental question is why these alphabets are used. Okay, that I will answer little further. The fundamental question is why these alphabets are used. Why we don't say that my digits are 10, 11, 12, 13, 14, 15. Any answers? Anybody knows why we use these alphabets and why we don't say 10, 11, 12, 13, 14, 15? Any answers? Anyway, that I will tell you because there is a reason. Okay, it's not like somebody felt that okay, let us use alphabets, but there are definite reasons. No doubt we use it in microprocessor, but still the question remains ki why we represent 10 as A. Okay, anyway, that answer I will give you. Yes, because what I can see, one answer is number system uses more than 9. That is partially correct, but anyway, let's not get into it right now. Now, if you observe my last two columns carefully, you will find that decimal number system is used by humans. Okay, I already said in initial 10 minutes, this system is for humans. We talk decimal. Binary number system is for machine, computer. Okay, and hexadecimal number system is used mainly in microprocessor. Okay, we will not talk in detail because this subject you will study in semester 4 after learning COA. But these are some applications where these number systems are used. Okay, you should be aware because people might ask you ki, what is the application of binary? Direct answer is all computers works on binary bits, zeros and ones. Where we use hexadecimal number system, very specific, we use in microprocessor. Octal number systems are outdated. Okay, they are not used anywhere. We don't find anywhere. But maybe 30 years back, these systems were used in old computers. So still we refer it. And in all, we have 4 number systems. Okay. Now the question is, yeah, I think I answered that question. Shantanu is asking where we use octal system. I think just now I said it is all outdated. Octal nowadays we don't use, but we always say that old is gold. And octal was originally used around 30 years back when computers were invented. So as a legacy, we refer to octal. Anyway, now comes our main discussion points after around half an hour. Question is how we move between these number systems, because I talk decimal, I'm a human. My machine talks binary bits 0 and 1 because it's a machine. My processor talks hexadecimal. How I can move between decimal to binary, binary to decimal, and that all comes under conversion. This is important for your exam. In your examination, around 5 to 10 marks of questions will come on this. Okay, minimum 5, may go up to 10. That is the weightage for this particular discussion. Okay, I have already said keep one notebook. What you feel important, note it down. My pace is absolutely friendly with you. Okay, so you can note it down. You can understand also. Okay, let's have all permutations and combinations. Okay, all eyes on screen. Observe it. Here we go. These are 4 number systems. Okay, decimal, binary, octal, and hexadecimal. Okay, decimal normally is for human. Binary is for machine. Okay, computer. Hexadecimal is for processor. Okay, this much understanding you have. Now the question is how my data which is in decimal will go in binary. How my data in binary will go in decimal? For that, we must understand conversions. Conversion between bases. Okay, conversion between these bases like this. Converting decimal number to binary and binary to decimal. Okay, so you can move this way, and this is most important so that I can communicate with the machine. As a human, I can talk to machine. Machine can talk to human if we know these conversions. So conversions are all numericals. Okay, there is an algorithm and there is a numerical. That is how it goes. You will see now. And they are all handy once you understand. You have to just solve it in your examination. So, second possibility, decimal to octal, octal to decimal, decimal to hexadecimal, hexadecimal to decimal, binary to octal, octal to binary, binary to hexadecimal, hexadecimal to binary, octal to hexadecimal, hexadecimal to octal. These are the conversions. Okay. Can you tell me how many total conversions are possible? Quick answer in chat box. How many conversions are possible? Let me check. What is a quick answer? How many total conversions? I just want a number in chat box. Let me see what is your response. Excellent. So this particular number is 12. That's a perfect answer. Okay. So these total conversions are 12. तो summary is that आपको 12 conversions अच्छे से आना चाहिए, तो आपके 5 से 10 मार्क कंफर्म. ओके, तो आज हम लोग उसमें से थोड़ा करेंगे, थोड़ा आगे जाएंगे. ओके, मतलब सेकंड सेशन में होंगे. एनीवे, सो how 12? Let me apply simple mathematics. Okay, no factorial and all that is required. It's simple multiplication. See, every conversion is a two-way conversion. Like I said, decimal to binary, binary to decimal. Okay, so 1, 2, 3, 4, 5, 6. 6 possibilities are visible. 6 into 2, total 12. So fundamentally 12 conversions you must know. Check if all is good and respond in chat box, so we can move. Is all is good? Yes, fantastic. Okay, now let's move on. Okay, अभी अच्छे से फोकस करना है क्योंकि हम लोग अभी एग्जाम की तरफ जा रहे हैं. मतलब ये क्वेश्चंस अभी एग्जाम में आते हैं. ओके, our initial background is very clear कि why we are studying number system and why we are studying conversion. Okay, why? That answer is important. Fine. You should be with your notebook because now numericals है, algorithms है, और ये पूरे पीपीटी पीडीएफ फॉर्मेट में मैं शेयर करूंगा. ओके, सो यू कैन रिफर इट आपके स्टडी के लिए. फाइन, let's start. We will start with little simple conversions, okay, so that progressively you will understand. Okay, you cannot be expert in one day, you can be expert in many years. Okay, so let's start progressively with simple conversions. Let's try to convert human data, decimal, because I talk human, into binary. Okay, so computer will understand. So if I want to tell computer add 45 and 50, then 45 decimal must be in binary. Okay, 50 decimal must be in binary. then only computer will process. What is the definition of computer? It's an electronic machine which processes the data. Which data? Binary data. Why? Because there are two symbols, 0 and 1. So let's start decimal to binary. Let's see what is the algorithm. Okay, now these algorithms will help you to understand how to solve numerical. Okay, you don't have to solve numerical just by looking at examples, but everything in computer has an algorithm. Understand? Okay, everything works through algorithm, so we need to understand the algorithm. So the algorithm is very simple. This is the algorithm. You can just go through. We will apply it. Okay. This algorithm is called division by target base. Observe it. What is the algorithm? Division by target base. Now, what is the target? Let me make you familiar. Target means to which number system और बेस यू आर कन्वर्टिंग. मैं कन्वर्ट किस में कर रहा हूं? बाइनरी में. ओके, तो ये जो है दिस इज माय टारगेट. दिस इज अ टारगेट बेस एंड दिस इज माय सोर्स बेस. सोर्स मतलब जहां से चालू होता है और टारगेट मतलब जहां पे खत्म होता है. ठीक है, तो टारगेट बेस मेरा है 2 और सोर्स बेस मेरा है 10. ठीक है, तो माय एल्गोरिथम इज डिवीजन बाय टारगेट बेस, मतलब मुझे 2 से डिवाइड करना है. ओके, लेट्स गो थ्रू द स्टेप्स क्विकली एंड देन वी विल अप्लाई. ओके, एवरी एल्गोरिथम स्टार्ट्स विथ स्टार्ट एंड इट एंड्स विथ स्टॉप. आपको पता है, आपने प्रोग्रामिंग पढ़ा है, शायद जर्नल भी लिखा है, सॉफ्ट या हार्ड. सो माय एल्गोरिथम स्टार्ट with word start, divide your decimal number by 2 because my algorithm is division by target base और मेरा target base है 2. okay, and you have to maintain remainder. okay, and your new dividend is a quotient. So what you have to do in simple words, you have to repeatedly divide number by 2, mark remainder, divide quotient, mark remainder, divide quotient, mark remainder, divide quotient. I repeat, mark remainder, divide quotient, mark remainder, divide quotient till division is possible. और डिवीजन कब तक पॉसिबल होता? जब तक डिविडेंड का मतलब है न्यूमरेटर इज लेस देन डिवीजर, मतलब डिनोमिनेटर, क्योंकि ये इंटीजर है. ओके, हम लोग अभी इंटीजर की बात कर रहे हैं. यू नो व्हाट इज इंटीजर? नंबर विदाउट फ्रैक्शन. फ्रैक्शन भी बात करेंगे आगे थोड़ा. ठीक है, वी आर ओनली टॉकिंग होल नंबर्स, नो फ्रैक्शंस. ठीक है, एंड फाइनली all remainders you have to take or you have to collect from bottom to top. That is your answer. This is a typical algorithm. ठीक है, now let's apply. आपको ये समझना है, आपको ये अप्लाई करना है. ओके, लेट्स अप्लाई. ऑब्जर्व इट. इफ यू वांट यू कैन टेक अ पिक ऑफ दिस फॉर योर रेफरेंस, या फिर अगर कुछ पॉइंट्स आपके नोटबुक में नोट डाउन करने हैं तो लिखो, क्योंकि नाउ आई एम गोइंग टू यूज इट. ओके, कैन वी गो अहेड? ठीक है, लेट्स अप्लाई. नाउ बी वेरी अलर्ट. लेट्स कन्वर्ट 125 डेसिमल, मतलब base is 10 in binary. Okay, this is a question. You can see 125 decimal you have to convert in binary. Okay, such type of questions you will find in exam. At the end of this session I will map it. Okay, I will map our discussion with exam. Okay, Let's start. Divide 125 by 2. This is my quotient. This is my remainder. Okay. Then you divide 62 by 2. This is my remainder. This is my quotient. Quotient is 31. Divide 31 by 2. Your remainder is 1. Your quotient is 15. Divide 15 by 2. Your remainder is 1. Your quotient is 7. Divide 7 by 2. Your remainder is 3. Correct? No, your remainder is 1 and quotient is 3. Divide 3 by 2. Your quotient is 1 and remainder is also 1. Okay. Divide 2 by 1. Okay. Divide 2 by 1. Am I correct? No. Divide 1 by 2 because division by 2. That is the algorithm. Your quotient is 0 and your remainder is 1. Why? Very simple answer. You cannot divide 1 by 2. It's an integer division. Okay. That means you don't talk fraction. And because division is not possible, you stop. And whatever remains is your remainder. That is 1. Okay. And since division is not possible, your quotient is 0. You stop here. Okay. And what you do, all these remainders, you have to collect from bottom to top. All these remainders, you have to collect from bottom to top like this. Observe it. See, 1, 1, 1, 1, 1, 1, 1, 1. Okay. 1, 0, 1, 1, 0, 1. This is your corresponding binary. So you have converted decimal number to a binary number. Okay. Now let me add some more points. If you observe this binary number carefully, then position of this particular bit. Now I will start using word bits. Okay, 0 and 1, it's called bit in binary. Position of this particular bit is 0. Position of this bit is 1. Position of this particular bit is 2. Okay. Now what is a position? Let me make you little more clear. See, if you take this 125 as a decimal number, let's take this 125 as decimal number as a reference, then position of this particular 5 is 0. Okay. Why? Because we start counting position from 0. And what is my base? My base is 10. And 10 raised to power 0 is 1. You are aware that anything raised to power 0 is 1. Okay, I'm writing a little faster, so you have to excuse for this handwriting because my main focus is concept delivery. Okay, so 10 raised to 0 is 1, and this is called units place. Okay, in school days, we have talked units place, tens place, okay, hundreds place. Now, why this is tens place? Reason is this position is 1. I already said 0, 1. That is how we count. And my base is 10. Okay, so 10 raised to power 1 is 10. So it is called tens place. Like that, in binary also, you start counting positions from 0. Okay, and the position with minimum position, okay, the position whose value is minimum, that it's called LSB. Observe it. you can see this particular bit has a position 0. This position is normally called weight. Observe it. WEIGHT. Weight means position of that bit or position of that digit. Okay, bit if you talk binary, digit if you talk decimal. Okay, like here position is 0. Digit 5 is at position 0. This is called weight. Or digit 2 is at position 1. This is called weight. Similarly, this bit 1 is at position 0. Okay, it is called weight. Position means weight. And bit with minimum weight, minimum means of course 0 in our case, it's called LSB. Can you tell me what is the full form of LSB? Anybody in chat box? Yes, it is called least significant bit. That is perfect. So why it is called as least significant bit? Because its position is 0. Its weight is 0. You have to remember this word, weight, WEIGHT. Okay. And in our binary, a bit with highest weight, you can see this weight is 6 because you can count 0, 1, 2, 3, 4, 5, 6. Okay, so this particular bit is having weight 6. Such bit is called MSB. And I think already answer is given in chat box. MSB stands for most significant bit. Why it is called most significant bit? Because its weight is maximum. Okay. Now you have to understand these terms and you have to use these terms frequently in our studies. Okay. LSB and MSB. When we study memory organization, there these terms are extremely important. When we study RAM, when we study cache memory, in that this reference is very important because how we store data in memory, reference comes from this discussion. Okay. Anyway, it's a long way. As of now, let's settle here. Let me summarize and take your questions if you have. A bit with minimum weight is called LSB, least significant bit. A bit with maximum weight, it's called MSB, most significant bit. Positions, we always represent using integer 0, 1, 2, 3 for all number systems. Okay, all number systems will have weight. All number systems counting will start from 0. Specifically for binary, we use a term LSB and MSB. Check if you want any further clarification. Otherwise, I will go to further discussion. So my question is, any questions? Please check if you have any questions and if you need any clarification. Like I said, if you want, you can note it down. These PPTs I will share in PDF. Okay, so directly you will study from this reference. We have to save our time and we have to use our time efficiently. So writing dictation part, I will keep it minimum. Okay, I can see there are no questions, but still I will wait for a few seconds. If anybody wants to raise any question, if anybody wants to understand some process again, I will repeat, check. And participate. Okay, you should always be active participation. That means yes, no, answer the questions. If it's wrong, okay. Anyway, I think all is good. Let's move on. Share the magic word. Let me check all is good. And let me check how many of you are sharing. That means so many are actively listening. That list should be long. Yes, I can see that list is long. Fantastic. I'm happy. Yes, that's the effective use of time and technology. Anyway, let's move on. ठीक है, आगे चलते हैं. अभी इसका अपोजिट करना है. ओके, इसका अपोजिट करना है मतलब सोचना ये है कि अगर एज ए ह्यूमन इफ आई गिव सम डेटा 125, my computer will take that data as 111111101. Okay, now let's try to do reverse. Let's try to convert binary into decimal. Okay, and here is the algorithm. Observe it. Let me erase this. Okay, of course that algorithm is multiplication, because if you divide to convert decimal to binary, to compensate, you have to multiply if you want to move from binary to decimal. So it is multiply by source base. Observe these words carefully. Previously, I have said divide by target base. See this. See this. Divide by target base. Okay. Now I am saying multiply by source base. और मेरा source base क्या है? 2. This is called as source. Okay. And this is called as target. I already said. Okay. Now what is the algorithm? Simple. You have to multiply every bit by 2 raised to n. Now why 2? Because it's the source base. Okay. My binary base is 2. That's why. And what is n? N is the weight. Okay. Just now I have talked about weight. That means position 0, 1, 2, 3. Okay. And what you have to do, you have to add all these particular products. So every bit you will multiply by weight 2 raised to n, and all these products you will add to get final result. Okay, so you have to repeat this multiplication depending on how many bits are there. Okay, let's see how we do it. And this is a direct example. Okay, now we can be little more towards understanding rather than now stepwise, because now we are in flow. So convert 101011 binary in decimal. That is a simple question. Observe it. This is my decimal. Okay, and of course this particular bit is my position 0. I think already we talked about it. So this particular bit is called LSB, whose position is 0. Then this is position 1, position 2, position 3, position 4, position 5. Okay, so what you do, you take this particular bit as it is, observe it. Okay, and multiply by 2 raised to n. Multiply by 2 raised to n. Why 2? Because 2 is my base, source base. And what is n? N is the weight. Okay, so you multiply 2 raised to 0 because this particular weight is 0. Then you take next bit, which is 1, observe it, and you multiply by 2 raised to 1 because this particular weight is 1. Okay, then you take next bit and you multiply by 2 raised to 2 because the weight is 2. Then you take next bit and you multiply by 2 raised to 3. Then you take next bit and multiply by 2 raised to 4. And you take MSB and you multiply by 2 raised to 5. This is a way you should present in exam. You will get full credits. Okay. It's a simple multiplication. Anything raised to 0 is 1. So this is 1. Okay, this is 2. This we will discard because we are multiplying with 0. This is 8. This also we will discard, and this is 32. And all this addition you will get final decimal, that is 43 in decimal. So 101011 becomes 43 in decimal. Check if you have any query in this particular conversion. If you have any question, of course I will answer that question. My question is, any questions? Waiting for responses. I can see there are no questions. We are good to move. Okay, let's go on. यहां तक अगर आपको समझा है, ओके, तो आगे के जो दो कन्वर्जन्स मैं डिस्कस करने वाला हूं वो सेम लाइन पे है. आई रिपीट अगेन, if these two conversions you have understood, next two conversions that I am going to talk is on the same lines. Okay, let me introduce. Let me remove this. Let me go back. Where we started. Okay, now see. What we have completed is decimal to binary. This conversion we did. And binary to decimal. This conversion we did. Okay. Now on the same lines, we will talk about two pairs, or I will say four conversions. Okay. One is decimal to octal. Okay, we will discuss this particular conversion. And decimal to hexadecimal, we will discuss this particular conversion. Okay, this is our next point of discussion. So today what I'm doing to keep our discussion little simple, I'm taking reference as a 10. This reference I'm taking from 10 to 2, 2 to 10 that we did. Now we will do 10 to 8, 8 to 10. Further we will do 10 to 16 and 16 to 10. So these conversions we will complete today. Okay, so 50% convergence we are trying to complete for the day. Anyway, let's go on with next convergence. Here we go. Okay, कॉम्प्लेक्स नहीं है, सिंपल है. थोड़ा लेक्चर या डिस्कशन के बाद मैं कुछ होमवर्क अभी आपको देने वाला हूं. नाउ यू विल सी, वो आपको सॉल्व करना है. ओके, वो आप सॉल्व करोगे तो आपको समझ में आएगा. ओके, कॉम्प्लेक्स इसलिए लग रहा है क्योंकि 12 कन्वर्जन्स है. अगर आप साथ में करोगे तो वो कॉम्प्लेक्स होगा, लेकिन स्टेप बाय स्टेप करोगे, जैसे आज हम लोग 6 करेंगे, नेक्स्ट फ्राइडे को बाकी के 6 करेंगे, तो वो एब्सोल्यूट मैनेजेबल है. ओके, और इंजीनियरिंग है तो इंजीनियरिंग तो थोड़ा कॉम्प्लेक्स होना ही है. एनीवे, लेट्स गो ऑन. Let me reach where we have completed. Yes, यहां तक हम लोगों ने डिस्कस किया. ठीक है, नाउ अभी आगे बढ़ेंगे. ये आपका होमवर्क है. ओके, you can take a pic of this and this is your homework. I will say homework number 1. What you have to do, you have to convert decimal to binary. All these numbers are decimal numbers. Okay, you have to convert into binary. And for the second question, you have to convert binary into decimal. All these numbers are binary numbers. Okay, this you have to convert into decimal. Okay, so take a pic and complete as a homework. Total 10 questions are there, 5 plus 5. I hope you must have taken a pic and we are moving ahead. Okay, let's talk decimal to octal. This process is exactly similar to decimal to binary. What we did for converting decimal to binary, my approach was division by target base. That is the algorithm. Algorithm remains the same. Data changes, algorithm remains the same. Okay, so my algorithm is division by target base. Same algorithm, same text. Observe it. Same things I have discussed some time before. Okay, the only difference is instead of dividing by 2, you will divide by 8. I repeat, instead of dividing by 2, you will divide by 8. That is the only difference. Otherwise, same algorithm, division by target base. This is called target and this is called source. My source is 10 and my target is 8. Okay, source मतलब जहां से चालू करना है, target मतलब जहां पे जाना है. ठीक है. Now I'll show you one more way how to represent this conversion. Okay, एक तो मैंने आपको already बताया. Observe it. This is one conversion that we did. ठीक है. थोड़ा इसमें मैंने animations वगैरह रखा है so that you can see the steps. Okay. Now let's make it little simple. For this particular conversion, we will use simple table. Observe it. Okay, this is more simple representation how to convert from decimal to octal. Okay, observe it. Question is convert 125 decimal, D for decimal, to octal. Okay, same process I am applying. Observe it. Take this number 125 and divide by 8. If you divide 125 by 8, your quotient is 15 and your remainder is 5. Okay, you can verify. If you divide 125 by 8, your quotient is 15 and your remainder is 5. Okay, is numerator is greater than denominator? Yes. Is numerator is greater than denominator? Yes. Continue with the division. 15 divided by 8, quotient is 1, remainder is 7. Okay. Is numerator is greater than denominator? No. So division will stop. So whatever is the last quotient, write it as a remainder. Okay, and next quotient will be 0. Why? Because division is not possible. So quotient is 0. And collect all digits from bottom to top. Okay, this way. Same, just like our binary conversion. So the octal number that you get is 175. So 125D, that means decimal, is equivalent 175 octal. Okay, same process, only difference, divide by 8 because that is your target base. Okay, let's continue with opposite. Octal to decimal. Okay, this is fourth conversion. Again, same algorithm, multiply by source. And what is my source? My source is 8 because that's my octal. And steps are also same. See. You must have noted only one difference in this algorithm. That difference is instead of multiplying by 2 raised to n, we are multiplying by 8 raised to n. बाकी सेम एल्गोरिदम है, सेम वर्ड्स है, जैसे वेट मल्टीप्लाई बाय 8 रेज टू n, n is the weight, repeat and add. Okay, so this process is similar to converting binary to decimal. Okay, this particular conversion, observe it. This one, the only difference is now you are going to multiply by 8 instead of 2. Okay, let's check it out. Question is convert 724 octal to decimal. Okay, convert 724 octal to decimal. Now you can see I'm taking first digit, that is 4, and you multiply by 8 raised to n. N is the position. This particular position is 0. You are aware position starts from 0. This position is 0, this position is 1, and this position is 2. Okay. So 4 into 8 raised to 0, then 2 into 8 raised to 1, and 7 into 8 raised to 2. Straight away you do multiplication, you will get partial product. Just add it. Okay, all these product you have to just add, like our algorithm says, you have to add all products. What you get is 468. So 724 octal is equal to 468 decimal. Check if you require any clarification in this particular conversion. So once again, my question is, any questions? Check if you have any questions. And now let's do one activity. Okay, before I go ahead, let me check who completes this activity quickly and who shares the right answer. Okay. Okay, now let's complete the simple activity. Activity is convert 15 decimal in binary. Let me check who can provide me the very fast answer. 15 decimal in binary. I'm waiting for your answers. Okay. Okay. Still you have 20 seconds. I want to see if any answer is different. Okay, I can see one different answer. Fine. One more different answer. That is why this question is given. Okay, your time is up. If you want to share, you can. But now let's see what is the correct answer. The correct answer is what majority of you are sharing. That is 1111. Okay, it's simple. My question was convert 15 in binary. Okay, so this is how we do it. If you recollect, we have to divide this by 2. Okay, I'm writing a little fast. So my quotient will be 7, my remainder is 1. Division is possible, so divide by 2. So my quotient will be 2 3s. Sorry, 2 3s are 6. 1 minute. Okay. Okay, 2 3s are 6, and my remainder will be 1. Division is possible, so divide by 2. 2 1s are 2, my remainder is 1. Division is not possible because 1 is less than 2. So this last digit remains 1 as a remainder, and my quotient will be 0. Collect all these bits, that is 1111. So 1111 is the correct answer. Okay. Anyway, now let's do second activity. There is one more question I'm going to give. I hope everybody is with notebook. Those who have calculated 010, or one more answer I have seen. Let me see what is the 010, 1001. You need to be little careful in the division. Okay. Anyway, my second question is convert a number 11111. Okay, there are 5 ones binary in decimal. Let me check who gets the correct answer quickly. You have to convert 11111. There are 5 ones binary in decimal. Okay. Let me check who are the quick answers. I think Ashraf has given, Divya has given, very good. Om has given. And many are giving. I just want to see if anything is deviating. Yes, the right answer is 31. I think it's simple because you have to multiply by weight. Okay. So let me show it here. 1, 1, 1, 1, 1. Okay. I'm little quick. So this is my position number 0. This is my position number 1. This is my position number 2. This is position number 3. And this is my position number 4. Okay. So anything raised to power 0 is 1. 2, 1 into 2 raised to 1 is 2. This is 4. This is 8. And this is 16. Okay. And if you add all these particular values, what you get is 16 plus 8 plus 4 plus 2 plus 1. Okay. And this comes out to be 31. Of course, because 8 plus 4 is 12, 16 plus 12 is 28, plus 2, 30, plus 1, 31. So this is the reference for your answer. That is the correct answer. Okay, let me ask one more question and then we'll move. My question is here. You have to convert a value 15 decimal in octal. Okay, I want very quick answer. Let me check. Purposely, I have given you simple value. What is 15D in O? Let me check the quick answers. Yes, Divya has given a quickest answer. Ashraf has given second quick. Ayush has given third one, and then it's following. Fantastic. No, there is one deviation. 715. It's 17. Okay, right answer is 17. I think same algorithm. If I want to again quickly solve, so this is 15, and I want to convert in octal, so I will divide by 8. Okay, and 8 ones are 8, remainder is 7. Further division is not possible, so I will write 7 as it is. Okay, and my quotient will be 0 because further division is not possible, and collect digits from bottom to top. Am I correct? Yes or no? Yes. The only difference is this is 7, because if you divide 15 by 8, remainder is 7. Okay, and further division is not possible, so here it will be 1. Am I correct? 15, 8 ones are okay, and this becomes 1, and then quotient becomes 0, and you have to pick up. Okay, same lines what we did here. Anyway, let's go for one more question. Again, let me check who gives the quick answer. My question is, you have to convert octal, value of octal is 20, O for octal, to decimal. I want quick answers. $20 octal in decimal. Yes, Sanjana has given quick answer, then Ayush, and then Mustan sir. I hope I am calling your name correct. And then all answers follow. That's perfect. Anyway, that's great. ठीक है, अभी हम लोग आगे चलते हैं. ठीक है, और 2 कन्वर्जेंस करेंगे, उसके बाद कन्वर्जेंस रुकाएंगे क्योंकि थोड़ा ज्यादा ओवर बर्डन होगा आपको. तो इसके लिए 12 कन्वर्जेंस है टोटल, उसमें से 6 आज करेंगे और बाकी के 6 नेक्स्ट फ्राइडे को करेंगे. ओके, दूसरा एक कंसेप्ट आज चालू करेंगे, डिस्कशन पॉइंट. ठीक है, दैट्स द प्लान. एनीवे, बिफोर आई प्रोसीड, लेट मी रेज वन क्वेश्चन. एनी क्वेश्चंस अप टू दिस? check. Okay, there are no questions. Looks good. Let me clear my screen. Meanwhile, if anybody wants to ask any question, you can. Okay, I think there are no questions. Let's move on. Once again, time to verify that all is alert, because we are working almost close to 1 hour 30 minutes. Type our magic words if all is good. It has to go a long list. Okay, there are many. And I must know that you are alert. Yeah, that's great. Anyway, let's move on. थोड़ा अभी एक 10-15 मिनट के लिए और अच्छे से फोकस करो, क्योंकि पता है थोड़ा जैसे आगे बढ़ेंगे तो थोड़ा कॉम्प्लेक्स लगेगा, क्योंकि टाइम फ्रेम में हम लोगों को उतना करवाना ही है, इसके लिए जाना पड़ेगा आगे. Now let's talk about one more conversion, and before that conversion, this is your second homework. Okay, so you can take a pic of this, and this homework is for 2 conversions, converting decimal to octal. Okay, there are 5 values, and converting octal to decimal, there are 5 values. Okay, so this is second homework. Take a pic, complete in 1 week, so you are well aware how conversions are done. I'm moving. Okay, now let's talk 2 more conversions, decimal to hexadecimal. Okay, algorithm is same. You know what is that algorithm? Division by target base. My target base is now 16. थोड़ा ट्रिकी होगा, क्योंकि you are aware in hexadecimal we use digits from 0 to 9 and alphabets A to F. A means 10, B means 11. So this division we have to do little carefully, okay, because alphabets will come. Process remains the same. Observe it. So we divide decimal number by 16. Okay, so the only fundamental difference is you divide by 1/6 instead of 2 or instead of 8. Okay, otherwise the process remains the same. Till numerator is greater than denominator, you continue division. The moment numerator is less than denominator, you stop and present your answer. Okay, now let's convert this algorithm into example. There is one question I can see in chat box. Yes, in this particular chapter, most of the concepts are numerical based. So nobody will ask you theory, how you convert number binary into decimal. Okay, this algorithm we require for solving the problem, because if you know the algorithm, you will able to solve the numerical. But most of the questions in this particular module, I will say around 80% questions are numerical and around 20% are theoretical questions. Okay, maybe in coming session, some concepts you will see today also. No, technically all these conversions you have to do by this algorithm. So you will not be allowed calculators for doing these conversions. Okay, because what is expected is that you must know the algorithm, and these algorithms are in your calculator. Now, how your calculator performs conversions in FE, you have done all these particular number systems. Probably you might have used. So it's because of all these algorithms. Okay, and this you need to solve using algorithms. Steps should be visible. So calcs will not be allowed. I think I have answered all your questions. But it's simple. I don't think that there is complex. Yes, if you try to do all together, you may find it complex. But if you do it in groups, then it will be simple, because basically what we are doing, we are dividing by 2 or 8 or 16, or we are multiplying by 2 or 8 by 16. That's all. Anyway, let's see how we do it. Question is, we have to convert 1, 2, 3, 4 decimal. Okay, this is a decimal number. Any random number I have taken, for example, to hexadecimal. Okay, now be alert, see how it goes. Take this number and divide by 16. Okay, if you divide 1, 2, 3, 4 by 16, your quotient is 77. You do it. Okay, 16 sevens are, yes, how much? 112. Okay, difference is 11. Okay, take this 4. Again, 16 sevens are 112. 114 minus 112. Difference or remainder is 2. Okay, your numerator is greater than denominator, so division is possible. 77 divided by 16. 16 fours are 64. Observe this step carefully. 77 divided by 16. 16 fours are 64. Okay, 77 minus 64 is 13. 77 minus 64 is 13, and 13 is represented by letter or alphabet D. Observe it. So I have written here D. Why? Because 13 digit in hexadecimal we represent using letter D. I think in beginning I have referred it. A means 11, sorry, A means 10, B means 11, like that, F means 15. Now my numerator is less than denominator, so division is not possible. You stop. So write this 4 as it is. Because division is not possible, quotient is 0, and collect all digits from bottom to top. Okay, same what we did previously for binary and octal. What we get is 4D2. So 1, 2, 3, 4 decimal is equivalent to 4D2 hexadecimal. So the process is not difficult. The only point you need to understand is your remainder. If it exceeds 9, you have to represent by alphabet. That is the extra requirement. Baaki almost identical hai. Okay. Now let's go for opposite conversion. That means hexadecimal to decimal. So this conversion is for hexadecimal to decimal. Okay, opposite. And my process or algorithm remains the same. Multiplication by source base. Okay, previously we multiplied by 2, then we multiplied by 8, now we multiply by 16. Same steps, observe it. With one difference. And I think everybody will identify that difference. That difference is you multiply by 16 raised to n. N is a weight. Okay. Let's map it to example. So this is a question. We have to convert ABC hexadecimal to decimal. We have to convert ABC hexadecimal to decimal. Okay. Let's start. Observe it, how it goes. I start with C. Okay. So C multiplied by 16 raised to 0. Because the weight is 0, let's write here. This particular weight is 0. This particular weight is 1. This particular weight is 2. Okay. Then B multiplied by 16 raised to 1 because weight is 1. Then A multiplied by 16 raised to 2 because the weight is 2. Now these alphabets we have to represent by actual digits. Okay, so my A in hexadecimal is 10, so it is 10 into 16 square. My B in hexadecimal is 11, so it's 11 into 16, and my C in hexadecimal is 12, so 12 into anything raised to 0 is 1. And just take partial product, add all these partial products. Okay, and what result we get after we add all partial product is the final decimal value, which is 2748. Simple addition. You can easily verify because I have aligned also properly. So quickly you can see, and we say that ABCH is equal to 2748 decimal. Okay, that completes converting hexadecimal to decimal. Okay, now comes one more question. That question is, check if you have any question or you need any clarification. Check it out. Waiting for your responses. If you have any questions, if no questions, then also you will respond. Okay, let me see. Okay, there are no doubts, no questions. You can go ahead. Okay. Okay, now let's do one quick conversion and then we go on with some concept. Okay, आज conversions यहाँ पे थोड़ा hold करेंगे क्योंकि I can see थोड़ा complex होगा एक दिन में, तो यहाँ पे हम लोग settle करेंगे. 6 conversions we did, but anyway, let me throw one question and let me see how quickly you answer. My question is, you have to convert decimal. You have to convert decimal. Let me write it here. 63 decimal you have to convert into hexadecimal. Let me check who can tell me the quick answer. 63D in H. Okay, I think Dhruvi has given quick answer. 3F is the answer. Let me check what others are telling. Okay, there is in between. Yes, I think slightly parallel is finding thoda complex. Let me help parallel. See, you have written 315, which is correct. Okay, so you're not wrong. The only step required is that you are talking hexadecimal, so that F you have to write instead of 15, because we don't represent 15 in hexadecimal directly. We represent using alphabet. Okay, so that answer is 3F. I'm waiting for some more answers. I want that you should try. Yeah, that's okay. थोड़ा होगा स्टार्टिंग में, क्योंकि थोड़ा हम लोगों को टाइम फ्रेम में जाना होगा आगे. इसके लिए आपको थोड़ा एफर्ट्स लेना पड़ेगा. ओके, जैसा लेक्चर होता है वैसे आप इमीडिएट पढ़ो उसको, तो हो जाएगा. एनीवे, आई एम एडिंग वन मोर क्वेश्चन, और एक क्वेश्चन ऐड कर रहा हूं. बी अलर्ट, लेट मी चेक हु कैन आंसर क्विकली, एंड आई वांट मेनी आंसर्स. ठीक है, माय क्वेश्चन इज, यू हैव टू कन्वर्ट a number Okay, that number is FF, okay, in decimal. Let me check who gives a quick answer. Yes, I think Ashaf has given a quick answer, which is 255. Ayush is 255, Dhruvi is 255, and it's perfect. So let me check everybody answers or not. It's 255, which is perfect. It's not 225. Ayush, I think your answer is 225. It's not 225, it is 255. Check it out. So I will change the position. Position 2 goes to Dhruvi and position 3 goes to Op. Check it out. It must be simple addition. Okay. Fine, good. Finally comes one more point, and that point is homework number 3. And this is your third homework where we are going to settle for the day, okay, for this convergence. And your third homework is you have to convert decimal to hexadecimal. There are 5 numbers and you have to convert hexadecimal to decimal. There are 5 more numbers. Okay, take a pick and complete this homework. I will ask in the next week whether you have completed or not. So sufficient homework is there for our session 1. Total 30 numericals are there. Okay, in every homework I have given you 10. 5, 5, 5, 5, 5, 5, that way. Anyway, I hope you have noted and you will complete this. All these marks are handy. Okay. Now you need to be alert because we are in last 30 minutes for this session. और उसमें मैं एक नया concept आपको सिखाने वाला हूं. Okay. As per our agenda, there are 3 points I started. Introduction to number system, common number systems, conversion between number systems. Okay, we did 6 conversions. And third point of our session 1 is introduction to code, CODE. Okay, so that I'm going to start. आपको अच्छे से सुनना है, कुछ important point है तो उसको note down करना है, ठीक है? There is one query I can see in chat box. What about floating point numbers? Okay, that's a good question. See, let me answer it. See, for floating point numbers, there is a different method how we represent those floating point numbers and how we convert. Okay, so definitely I'll be talking floating point numbers, but not in today's session, in coming session. Okay, so answer to your question is floating point numbers are coming. Okay, for representation, how we convert. ठीक है, क्योंकि उसका एल्गोरिदम थोड़ा अलग है और वो भी करेंगे लेकिन स्टेप वाइज करेंगे. ओके, लेट्स गो ऑन and let's talk a concept of standard code. Okay, now what is a concept of code? Code means it's a standard way how we store the data. Okay, now let me make you little more clear about this statement. What is a standard way to store the data means what? Okay, let me make you little more clear. Suppose I want to represent my data in binary. Okay, you know how we convert decimal into binary. That convergence we did sometime before. But now next requirement is, let us say my number is 2. ओके 2 का बाइनरी क्या है क्विकली चैट बॉक्स में व्हाट इज द बाइनरी ऑफ वैल्यू 2 10 करेक्ट वेरी गुड ओके सो लेट मी राइट हियर 2 का बाइनरी है 10 ठीक है वेरी गुड व्हाट इज द बाइनरी ऑफ 5 क्विकली चैट बॉक्स में 5 का बाइनरी क्या है क्विक 5 का बाइनरी क्या है 101 वेरी गुड ओके तो 5 का बाइनरी है 101 ठीक है वेरी गुड व्हाट इज द बाइनरी वैल्यू ऑफ 9 क्विकली व्हाट इज द बाइनरी वैल्यू ऑफ डेसिमल नंबर 9 क्विकली 1001 very good fantastic so let's write 1011 ओके अभी आपको अच्छे से ध्यान देना है जो मैं अभी आपको बता रहा हूं ठीक है क्योंकि एक क्वेश्चन मैं आपको पूछने वाला हूं इसके लिए आपको ध्यान देना है ठीक है डेसिमल वैल्यू 2 बाइनरी इज 10 डेसिमल वैल्यू 5 binary is 101 decimal value 9 binary is 1011 okay that means if you observe very carefully you will find that every digit requires different bits जैसे 2 I represent using 2 bits 5 I represent using 3 bits 9 I represent using 4 bits okay yes 9 is 1001 it's my writing mistake शायद मैंने chat box में बताया अभी 1001 okay let me correct it thank you 1001 करेक्ट है मैंने शायद चैट बॉक्स में बोला भी कि ये करेक्ट है करके okay fine let me see who has identified because Mustansir okay I hope I'm calling you by correct name I'm sorry if I'm not able to call you anyway fine come back 2 का बाइनरी है 10 ठीक है 5 का बाइनरी है 101 9 का बाइनरी है 1001 ठीक है अभी इसका ऑब्जर्वेशन ये है कि एवरी डिजिट रिक्वायर्स डिफरेंट बिट्स ओके जैसे अगर मुझे 2 को रिप्रेजेंट करना है डिजिट 2 को तो मुझे कितने बिट्स चाहिए 2 5 को अगर रिप्रेजेंट करना है तो कितने बिट्स चाहिए 3 9 को रिप्रेजेंट करना है तो कितने बिट्स चाहिए 4 इसका मतलब है अगर ये डेटा मुझे स्टोर करना है तो उसमें थोड़ा स्टैंडर्डाइजेशन की जरूरत है क्योंकि हर एक डिजिट के लिए अलग अलग बिट्स लग रहे हैं देखो ये जो 2 है उसको कितने बिट्स है 2 बिट्स है ओके 5 के लिए 3 बिट्स है मतलब वेरिंग नंबर ऑफ बिट्स आर रिक्वायर्ड फॉर एवरी डिजिट so what we need some standardization so that all the digits will require equal number of bits that standardization is called code I repeat again please understand conversion is different and code is different please understand conversion and code they are different conversion is what we did okay small algorithm and then apply that is called conversion but after you do conversion what we require is a code and why we need code for some standardization it's a standard way how to store the data it's a standard way how to present the data okay you will understand in next slide okay जैसे थोड़ा एक एग्जांपल लेंगे तो आपको समझ में आएगा लेकिन ये उसका बैकग्राउंड है okay let me go ahead conversion transforms data from one base like decimal to another base like binary ओके, ये हम लोग ने देखा है, जैसे अभी सामने है कि 2 is my decimal, 10 is a binary, 5 is decimal, 101 is binary, 9 is decimal, 1001 is binary. Okay, so this is a transformation. This is for human, this is for machine. But code is used to store this data in a standard form. मतलब आप कन्वर्जन करोगे और उसको अगर स्टैंडर्ड फॉर्म में कन्वर्ट करना है, स्टोर करना है, देन वी यूज अ कंसेप्ट ऑफ कोड. ओके, सो कोड एंड कन्वर्जन, दे आर डिफरेंट. ओके, देयर थॉट इज डिफरेंट. फाइन, लेट्स take one example where you get little more clarity. One very common code is called BCD. Okay, anybody who knows what is the full form of BCD, quickly in chat box. One standard code is called BCD. Anybody who knows what is BCD? Just a full form. Okay, I want full form. BCD. B question mark C question mark D. Just a simple sequence of alphabets. Yes, that's right. Binary coded decimal. So what is basically BCD? B for binary, C for coded. That means we are talking about some standard code. D for decimal. That means this we use for decimal numbers. Okay, BCD is a code we use only for decimal numbers. I repeat again, BCD is a standard code we use explicitly for decimal numbers. So if somebody tells you how you will represent hexadecimal number in BCD, answer is not possible, because BCD is explicitly for decimal number system. Okay, let's understand what is BCD. Here we go. BCD is called weighted code. Observe the word. Okay, BCD is called weighted code. What it means, in BCD we represent every digit using 4 bits. Listen my statement carefully. We are in last 20-25 minutes. In BCD we represent every digit in using 4 bits. BCD में कितने बिट्स रहते हैं? हमेशा 4 बिट. ओके, जैसे ऑब्जर्व इट केयरफुली. ये मेरा पहला कन्वर्जन है. ओके, ये मैंने आपको बताया. ठीक है, लेट मी रिमूव ये टेक्स्ट, थोड़ा निकाल देता हूं तो मुझे एक्सप्लेनेशन करना थोड़ा इजी होगा, आपको दिखेगा. ओके, ऑब्जर्व. 2 is my decimal. What is a binary? 10. 5 is my decimal. What is binary? 101. 9 is my decimal. What is binary? 1001. Okay. Now what we do, if I want to represent 2, I will represent 2 always using 4 bits. Matlab 0, 0, 1, 0. If I want to represent 5, I will represent 5 always using 4 bits. Matlab 0, 1, 0, 1. If I want to represent 9, no extra efforts, because 9 में already 4 bits है. I will represent using 4 bits, 1, 0, 0, 1. Now you can see this is called C for conversion and this is called C for code. This code is called BCD. That's why I've said code and conversion, they are different. Conversion means you get raw bits and code means you make it more standardized. Okay, you pack it. Okay, I repeat again, in BCD we always represent numbers. Which numbers? Only decimal numbers using 4 bits. Okay, और अगर उसमें 4 बिट्स नहीं है, जैसे दो रिप्रेजेंट करने के लिए मुझे कितने बिट्स लगेंगे? 2, 1 0. देन यू ऐड जीरोस ऑन एमएसबी, क्योंकि जीरो अगर एमएसबी में ऐड करेंगे तो वैल्यू चेंज नहीं होगा. अगर आप जीरो एमएसबी में ऐड करेंगे, एमएसबी मतलब मोस्ट सिग्निफिकेंट, ओके, वो साइड में अगर आप ऐड करोगे तो आपका वैल्यू चेंज नहीं होगा. जैसे मेरा अगर डेसिमल नंबर है 9, I can write 9 as 09. My value is not changed. Or if my number is 20, I can write 20 as 020. Value doesn't change. So I can add any number of zeros on MSB. That we use in BCD. And every digit decimal we represent using 4 bits. Okay, that is called binary coded decimal. This is one standard code. Okay. Anyway, let me bring those points what I was talking. Okay, see now. If I want to represent 3, then I will represent it as 0011. Why? Because actually my 3 I represent as 11, लेकिन BCD में हमेशा 4 बिट्स से रिप्रेजेंट होता है, तो 2 बिट्स ऐड करूंगा MSB में, so it becomes 0011. Okay. Same what examples I was talking. ठीक है. Now why it is called weighted code? Observe this word. Okay, BCD is called weighted code. Why it is called weighted code? Reason is ये जो 4 positions है, okay, that we always represent as 0, 1, 2, 3. You already know it. Okay, around 2 hours before हम लोग ने यहाँ से ही चालू किया था, if you remember. Okay. And because every bit has a position, जैसे LSB का position है 0, MSB का position है 3, because every bit has a position, this code is called weighted code. Okay, just alternate name. BCD is called weighted code. Okay, and positions are 2 raised to power 0, मतलब ये 1, 2 raised to 1 मतलब 2, 2 raised to 2 मतलब 4, and 2 raised to 3 matlab 8. So those weights are 8, 4, 2, 1. 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. Okay. अभी मेरा क्वेश्चन ये है, how many digits you can represent using BCD? I repeat again, I want quick answer in chat box. My question is, how many digits you can represent using BCD? I repeat my question. मैं क्वेश्चन चैट बॉक्स में शेयर भी करता हूं. How many digits can be represented using BCD? Okay, I can see varying answers. Little tricky question. How many digits can be represented using BCD? I'm expecting answers from everybody. I'm just waiting for a few more seconds so that everybody can share their answers. Question I already have shared in chat box. How many digits can be represented using BCD? Okay, let me answer this question. Using BCD, you can represent 10 digits. If you are good listeners, I have very clearly said BCD is explicitly for decimal number system. You cannot use BCD for any other number system. And in decimal, there are total 10 digits, 0 to 9. So using BCD, you can represent numbers from 0 to 9. So total 10 digits you can represent using BCD. Why? Because it is only for decimal number system. How many bits you will require? 4 bits. That is correct. So in BCD, we use 4 bits to represent every number. Okay. My next question is, because I can see some answers are 1-5. Okay. Many people, they have answered as 1-5, 15. Okay. So my next question is, which numbers are invalid in BCD? I repeat, my question is, which numbers are invalid in BCD? Okay, let me answer one question. By the time your answer comes, there is a question, and I think Tanisha has asked this question. Why 10? Okay, let me answer it. Why 10? Answer is, I have already said BCD is a number system in its full form. Very clearly we can say binary coded decimal. See this word. Okay, I'm highlighting that word, decimal. That means BCD is explicitly used for representing decimal number system. And decimal number system में total 10 digits है 0 to 9. That is the reason we can only represent numbers from 0 to 9. That means total numbers are 10. Okay, that is the reason answer to the question by 1 minute. Let me go to that question. Yeah. Answer to the question by Tanisha, why we can represent only 10 digits, because it is for decimal number system. Okay, और decimal में 10 digits रहते हैं 0 to 9. Okay, अभी मेरा क्वेश्चन था कौन से नंबर्स इनवैलिड है. ओके, उसका बहुत ही सिंपल आंसर है. लेट मी ब्रिंग दैट आंसर इन प्रेजेंटेशन. ये थोड़ा मैं इरेज कर रहा हूं सो दैट यू कैन रीड इट. ठीक है, और यहां पे वो आंसर है there are total 6 different values which are invalid, and those values are A, B, C, D, E, F. ओके, क्योंकि टेक्निकली स्पीकिंग अगर थोड़ा आपने सोचा तो यूजिंग 4 बिट्स आपको टोटल 16 पॉसिबिलिटीज मिलते हैं, और उसमें से 10 आप यूज कर रहे हो बीसीडी में, तो बाकी का जो बचता है वो 6, एंड दैट 6 पॉसिबिलिटीज आर A to F. जो हेक्साडेसिमल नंबर्स है वो हम लोग बीसीडी में रिप्रेजेंट नहीं कर सकते. Again, the answer remains the same because BCD is for decimal. Okay, so that is a simple answer. Okay. Now let me ask one more time. If you have any questions, then definitely I will answer your question. So my question is, any questions? Check it out. Okay, there is a question, sir. Can you show first standard code slide once? Yeah, I will go to the previous one, definitely. And this I'll be sharing. Okay, anyway, I will show you. But this is to Ritvik. I'll be sharing this in PDF, okay, for your studies. कल मैं ऑफिस के साथ शेयर करूंगा, and you will get it in our app, maybe in 1 or 2 days. Okay, ये मेरा पहला स्लाइड था कोड के बारे में. This was my slide related to what is a code. Okay, Shantanu is asking why hexadecimal numbers are invalid in BCD. That's a good question. See, the answer is BCD is a system we use to interact with humans. Okay, let me give you one example. मतलब ये example थोड़ा आपको difficult लगेगा, लेकिन बिना example से मैं आपको ये आंसर को नहीं कर सकता. इसके लिए I am giving you example. Okay, I am answering one question: why hexadecimal numbers are invalid in BCD. ठीक है. Example is that decimal नंबर सिस्टम वी यूज टू इंटरेक्ट विद द यूजर. ओके, जैसे आपका जो फ्लोर इंडिकेटर है, कभी आपने अगर देखा होगा आपका फ्लोर इंडिकेटर, तो हमेशा आप डेसिमल नंबर सिस्टम में ही आप वो फ्लोर रिप्रेजेंट करते हो. जैसे अगर आप 15th फ्लोर पे हो तो यू डिस्प्ले 15. आप कभी भी एफ डिस्प्ले नहीं कर सकते. ओके, क्योंकि जो बाकी लोग हैं उनको पता नहीं चलेगा एफ का मतलब क्या है. या अगर आप 14th फ्लोर पे हो तो यू डिस्प्ले 14, यू नेवर डिस्प्ले ई. अगर आप 10th फ्लोर पे हो तो यू डिस्प्ले 10, यू नेवर डिस्प्ले ए. हेक्साडेसिमल में आप हमेशा ए यूज करते हो 10 के लिए, या 15 के लिए एफ यूज करते हो. सो माय पॉइंट इज दैट in normal day-to-day life we always talk about decimal number system, and that is the reason BCD only talks about decimal number system. BCD never talks about hexadecimal. Hexadecimal is only for microprocessor, जो मैंने पहले स्लाइड में आपको दिखाया था. ओके, दैट्स द आंसर टू योर क्वेश्चन. एनीवे, ये पहला स्लाइड है शायद. Yeah, definitely. We are going to summarize. Okay, and we are going to 1 minute. Yeah, definitely. We will be in last 5 minutes. Okay, एक समरी करके आगे के बारे में प्लान करके हम लोग रुकेंगे. Okay, definitely. Time is important. Okay, now let me summarize and let's create some background for next Friday. Okay, so last 5 minutes and then we will summarize for the day. Today we introduce number system, 4 number systems: decimal, binary, octal, and hexadecimal. Okay, most commonly used are 2: decimal for human, binary for computer. Binary means bits, zeros and ones. Octal we never use. Hexadecimal sometimes we use in microprocessor. Then we understood what are the different conversions between number system. Total 12 conversions are there. Out of that, 6 conversions we completed. Okay, and a lot of practice homework I have given you. In the next session, next Friday, we will talk about remaining conversions. Okay, so needless to say, आपको ये अच्छे से पढ़ना है. फिर हम लोग आगे बाकी के जो कन्वर्जन्स है उनके बारे में डिस्कस करेंगे. ठीक है. So what is coming in the next week, next Friday, is remaining conversions. Okay, we started discussion of standard code. I said code and conversion, they are different. Code is for standardization. Most common code is BCD. Okay, binary coded decimal. It is explicitly for decimal number system. So digit 0 to 9. Every digit we represent using 4 bits. That's the standard. For that, we may add some extra zeros on MSB. I think examples we referred. Okay, it's visible here. 3 is 0011. Okay. Using this, in coming session, we are going to introduce one more code that is called gray code. Okay, GRAY. ओके, आपके सिलेबस में 2 इंपॉर्टेंट कोड्स उन्होंने मेंशन किए हैं. इनफैक्ट 3 किए हैं. एक बीसीडी, दूसरा ग्रे कोड, और तीसरा एक्सेस, EXCEES. इनफैक्ट EXCSS, एक्सेस 3 कोड. ये 3 कोड्स उन्होंने दिए हैं. दैट वी विल बी इंट्रोड्यूसिंग ग्रे कोड इन कमिंग सेशन. ओके, एंड एक रिमाइंडर कि नोटबुक होना जरूरी है, क्योंकि ये सब ये है कैलकुलेशन पार्ट है। ओके, तो उसमें नोटबुक जरूरी है। नाउ लेट्स डू लास्ट एक्टिविटी बिफोर वी एंड फॉर द डे। जस्ट गिव मी अ मिनट, मैं क्वेश्चन पेपर आपको दिखाता हूं तो आपको समझ में आएगा इसका मैपिंग कैसे होता है। ठीक है, जस्ट गिव मी अ मिनट। ओके, मैं एक लेटेस्ट पेपर आपको दिखाता हूं। Okay, now let me open it. Okay, this is the latest question paper. Okay, अभी जो एग्जाम हुआ था वो ये क्वेश्चन पेपर है। आई होप इट इज रीडेबल। मैं थोड़ा और जूम करता हूं उसको सो दैट यू कैन सी क्लियरली। अभी देखो ये क्वेश्चन नंबर 1 देखो। नाउ यू कैन सी क्वेश्चन नंबर 1 which is a compulsory question. Okay, see now, this is the questions that we did today. Observe it. 147, convert 147 in binary. See this. Then convert 23A in decimal. Convert 135 octal in decimal. 234 in BCD. तो इस ये क्वेश्चन में से 4 आपको सॉल्व करने को आना चाहिए आफ्टर सेशन 1. You should able to solve this one. You should able to solve second, third and fourth. So this is the type of questions you normally get in your final examination. और अगर थोड़ा आप लकी हो तो कभी कभी 10 मार्क के लिए भी आता है। मतलब they will give little larger number and they will tell you to convert in binary or maybe decimal, octal and all that. Okay, so this is a recent question paper just for your reference to map whatever discussions we did, how it comes in examination. Okay, anyway, maybe for the last time, my question in chat box before we end is any questions, please check it out. Okay, so there are no questions. Fine, it's a good start. Let's keep it up and take some efforts. Okay, let me remind you with last 2-3 statements. This particular subject is pure conceptual subject. Okay, तो उसमें आप याद रख के कुछ होगा नहीं, आपको समझना पड़ेगा. And lot of numericals are there. Typically module number 1, chapter 1, chapter 2, चैप्टर 2 तो पूरा न्यूमेरिकल बेस्ड है. मतलब बहुत सारे एल्गोरिदम्स है, जैसे बूथ्स एल्गोरिदम है, BOOTH, या रिस्टोरिंग डिवीजन, नॉन रिस्टोरिंग डिवीजन, ये पूरा न्यूमेरिकल पार्ट है. चैप्टर 1, चैप्टर 2 मेमोरी में, कैश मेमोरी में छोटे न्यूमेरिकल्स है. सो I can say around 30 to 40% of this particular subject is numerical. ओके, सो आपको प्रैक्टिस करने होंगे. मैंने काफी एग्जांपल्स आपको दिए हैं. ट्राई टू सॉल्व इट एंड आफ्टर एवरी सेशन यू ट्राई टू स्टडी. ओके, सो दैट our next sessions will be more fruitful. Okay, and every session will start with QA, that is question answer. तो आपको prepare करना है. Anyway, thanks a lot for your cooperation. That was a great start. Okay, one more question which is not related to subject, but I will answer it. There are 2 questions in fact. Which language? Okay, programming languages, if you are asking, then you must know C, you must know Java, you must know Python. These 3 programming languages is must, MUST capital. And what is the weightage of this chapter? I think in the beginning I said this weightage is around 5 marks up to 10 marks. Okay, that is a typical weightage for this particular chapter, and most of the part is numerical. Anyway, I think I have answered those questions also. So thanks a lot. That was a great start. Let's meet next Friday, same time, 6:30 in the evening. Okay. And have a nice weekend. Thank you so much. Anybody in the office? My session is complete. We can end the session. Thank you.
Okay, sir. Good night.
Good
Bye.
night. Thank you.
Thank you.
Yes, thank you. Take care.